Not only do we see this sudden, complex, diverse beginning right from the start, as you continue upward, you see that there are separate and distinct kinds throughout the record, not this progressive continuum. Quoting here from Discover magazine of a few years ago, they're describing this lowest part and then the continuing fossil record. This demonstrates, we're told, that large animal phyla of today were present already in the early Cambrian, and that they were as distinct from each other as today. Now, they're not just gradually leading one from one to the other. They're just as distinct as you see today. A menagerie of clam cousins, sponges, segmented worms, other invertebrates that would seem vaguely familiar to any scuba diver. Now, mostly invertebrates at the bottom of the ocean, which I think is the environment we're looking at. But we do have vertebrates there. But they're the kind of things that any scuba diver would recognize, and they're separate and distinct right from the start, just as they are today. Where's this progressive continuum that the evolutionist would be looking for? We read from Valentine and Irwin, two of the leading evolutionary biologists in the world, writing in their textbook Development. If we were to expect to find ancestors to or intermediates between higher taxa, it would be in the rocks of the late Precambrian or Ordovician time. These are the earliest Precambrian, Cambrian, Ordovician, the earliest. That's where you'd expect to find the ancestors of the higher taxa. But that's when the bulk of the world's higher animal taxa evolved, he believes, right there at the start. Yet traditional alliances are unknown or unconfirmed for any of the phyla or classes appearing in them. Now, Gould acknowledged they were all right in the Cambrian explosion, the lowest part of the Cambrian. He widens all the way up to and including the Ordovician, but even including that, you find no connecting branches. You find unknown intermediates for any of the phyla or classes. They're not connected. They're separate and distinct, and this is their acknowledgement. Yet, when you look in the biology textbook, what do you see? You see the tree of life, and they're all connected. Well, they're not connected in the fossil record. They're distinct and separate. The lines are drawn by the evolutionist and arranged in this pattern because that's the theory. That's not what the fossil record tells us. In fact, Stephen Gould says the evolutionary trees that adorn our textbooks have data only at the tips and nodes of their branches. The rest is inference, however reasonable, not the evidence of the fossils. So when you see these connected branches, these trees of life, understand, even the leading evolutionists acknowledge, this is not what the fossil record says. This is very different. They have connected it in the textbook. But what causes them to connect it in this manner? What allows them to arrange it this way? Well, not the fossils. What did do it? Before we get to that point, notice Gould acknowledging that what you really find in the beginning is this broad, diverse picture, very much like the top of the tree. If you turn it upside down, it would be closer. He says the sweep of anatomical diversity reached a maximum right after the initial diversification. Right at the beginning, you've got more diverse kinds than later. He says the later history of life proceeded by elimination, not expansion.